I should mention, there is a hacking workshop tomorrow, and there'll be lockpicking at 1. So there's not one on Saturday, but there is one on Friday. Not tomorrow, but Friday, 2 days away. So come to that if you like. It's worth extra credit. And I imagine lockpicking may appeal even if people don't want to be in the hacking part. But if you do them both, you'll get even more extra credit. And today we're going to go through more of Android internals in pretty considerable detail using this app called Civ. And then I have some new projects to show you, including some confidential projects where I'll have to conceal access to the demonstrations I'll show you, but I figured out how to do that. So Civ is this application, and I found out something just earlier today. Civ was written by your textbook authors to demonstrate some security vulnerabilities, and the problem is it was pretty old and out of date, and it only worked on, I think, a 32-bit ARM processor, which almost none of the emulators can run. So it was getting really hard to use, so I took it out of the course a couple of years ago, but somebody updated it finally last year. So now there's an updated version of it that runs on a modern emulator, and that's very nice. So I can now demonstrate this stuff properly again. So we're going to talk about attacking application components, and the main thing you learn here is details of how the components of an Android app work and how you attack them. So you have trust boundaries. Now an Android app component can be controlled using intents. Intents are signals inside the operating system from one app to another or from one app to itself. And like when you click a button you tap a button to launch an app, that sends an intent to launch the app. That's the electronic signals that go behind there. And so there are no default boundaries. You can write an app where everything is just wide open. And I've been testing hundreds of apps again. A lot of them are that way. Like it's just app is basically just a book. There's no security. There's no login. There's no limitation. It's just a bunch of pages. You can view things. You can write an app like that with no security boundaries at all. But usually you do have security boundaries. So if you download, this is the new version in a different GitHub repository. And so let me put this on my emulator here. So here's my emulator. And I just want to get there. All right, and so I'm going to drop Civ on there, and there's Civ. And I can just drop the APK on there, and I think it's on there. Let's sweep up and see. It's on there. It doesn't take long to install. It's not very big. And the point of Civ is it's a password manager. And it is, of course, a terrible password manager with every possible flaw. That's the point. So when you launch Civ, it's going to ask you for a master password that has to be 16 digits long. So I put in password 1, 2, 3, 4, 5, 6, 7, 8 twice. Sort of thing that might make someone think it's secure, although we're going to see it isn't. And let's see, and then I click submit. Okay. Now I have to give it a PIN, so I'll give it 1, 2, 3, 4, and 1, 2, 3, 4, and submit. So now I've got the password manager going. All right, so I put it, now I'm going to close it. I'm not going to do any more at this point. So I sweep up from the bottom, and then I drag this off the top to close it. And it's a little tricky, but there we go. All right, so now we can open Civ, and we will notice a flaw already. If you just open Civ here, you can enter password, but notice without logging in, you can get to the settings page. And that's a mistake. This is insecure direct object access. This is extremely common. It just hit Microsoft Azure. A report just came out that this guy found a way to become domain administrator in everybody's domain in the world on Azure Entra. And he told Microsoft, and they passed it before anybody else figured it out. But it was this. There was a way to make a request that did not verify who you were. It just let everybody in. This keeps on happening. People have some software and they have some login process, but then somebody adds another feature. So they add another entrance point and they forget to connect it to the login part. So there's some part of it that forgets to check who you are before letting you do something. So that's not good. All right. Now let's take a look at the exported components. I think I've got this already set up because I wanted to test it, but let me just do it again. This is what I tried to show you last time that did not work. Now, with the modern version of Civ, it works. If you want to analyze an app, the way to do it is just take the APK file and drop it in the middle of Android Studio. And now it will just let you see the components of the app. This is really nice. In my early days, I did all this in the command line with APK tool, but with this and JADX GUI, you can use these, you don't really need to. So here you see the components of the app. Here, here's the Android manifest, for example, which is extremely useful. And that should be, it's opening down here in another little window. So I'm going to make it bigger, and we're going to look in this manifest a bit. The manifest is the part that tells what the components of the app are, and it also specifies the security boundaries for it. So, yeah, it's complaining, there's always something. Anyway, so, all right, so you can see, look at the manifest, and we're going to find the file select activity. So here's general information about the app, like what version of Android it wants to run on, and what kind of permissions it uses. These are permissions it will ask you when it's time. And here's, it defines some of its own permissions, read keys and write keys. And here, more general information. And here's activities. Activities are pages you can see. Here's the main login activity. When you tap the button to launch the app, this is the one that launches, the main activity. That's the first one. All right. And so it's exported, which means you can reach it from outside the app, which it would have to be, so you can get it if you launch the app. All right. So that's the simplest thing. And then there's a file select activity down here too. This is it. And you see this one is also exported, which is kind of strange. Exporting it means other apps can request this service. And you probably don't want to let other apps request this service. You probably want other apps to only get to the login screen and let all the rest of it require that you go through the login screen first. But that has not happened here. And we'll see that that's a problem. All right, so there's two other exported activities, main login and PW list. The file select is not quite clear what that is, but this one looks pretty bad. Password list is exported. That would suggest you can jump straight to view the password list without going through the login screen, which would be a bad thing, obviously. All right, so there's the exported activities. These can be started from any app, and there's a bunch of other activities that are not exported, so they have to be launched from the Civ app itself or from somebody logged in as root. And this is one of the many reasons why many apps will refuse to run on a rooted phone. A rooted phone is an intrinsically unsafe environment to run an app in, and that for this reason, their security boundary is kind of obviously compromised. So you can launch them with ADB in the command line. So let me get this open and make it bigger and shove it to the side. All right, and so I got that, and let's get the phone up here. All right, and so I'm going to, I guess I'll leave it the way it is for the moment. And let me just close the app first. It's probably easier to see if you close this first. Let's close. Okay, now Civ is not running. Now I'm going to launch the main login activity, and you can do it with the AM command on the phone. Activity Manager. You just have to, it took me a while to get this working earlier. You have to get the right path here with exactly the right features. So I'm going to go to here. Okay, now I do ADB shell. All right, and now I'm on the phone, but I'm not root. You see a $sign. But I don't need to be root to activate the main login activity. There I go, starting the main login activity, and that launches it. So it launches showing the main activity. That makes sense. Now, let's close it again. I'm just going to do this again so you can see the phone while it's happening. Let's get this phone ready. All right, now if I run that again, that launches it just like if you tapped it. So that's reasonable. All right. And now, if I can drag this thing out of the way, there we are. Now this one will launch the file select activity, which we saw was also exported. So let's find out what happens if we launch that one. Put the phone up here. All right, there we are. The file select activity, there it is, it opens, and it shows you where the files are and lets you do something. So it lets you see the files. So not clear that this is too bad, but it's kind of unprofessional. That's probably something you shouldn't be able to see until after you log in. So, all right, now let's try the unexported activity, like the settings activity. Here's one, if I just have to copy it. But that long path is a little bit tricky to get right. All right, so let me close this again. All right, so if I try to go straight to, get to the desktop, so I try to go straight to this activity, instead I get a screen of error messages showing a security exception, permission denial. You are not allowed to go to that activity because it's not exported. You can't run it from another app, which like this terminal counts as a non-administrative app right now. I have to be super user. So I'll elevate to super user, and the phone will ask for permission to grant this because I'm using the root exploit that we in one of the projects. So now I'm super user. Now I can do that same thing we just did from the settings activity, and now it works. because the root person can launch every activity, even the unexported ones. So that's all right. That's all I wanted to show you there. And it's the so that's activities, the visible pages. Another thing is content providers. Those are the databases that store things. So we're going to create some content. I think I'll start the app clean. I probably could continue from here, but that launched as root, and that may have some weird effect. I'm going to launch it normally. Okay, now I have to log in with my super secure password, a password 1, 2, 3, 4, 5, 6, 7, 8. And it also requires, please press the add button to add your password. So I add, okay, I'll add a CCSF, this garbage. Okay, everybody has to pop up their stupid new features I don't want. Anyway, so, okay, sam@ccsf.edu, and password. I use the same Microsoft password I always use, PADSSW0RD. All right, so now I've added a password to my password manager. I will save. Okay, so now there's some data in the database. This is going to pop, I'll have to put it in a Google Password Manager, but I'm not going to use that. That's an internal phone feature, a lot better than this password manager, but that's not what I'm trying to do right now. So now, remember, content providers are automatically exported for really old versions of Android, but for modern versions of Android, they are not exported unless you export them. So if we look at the manifest, we can find the providers. And let's just do that. That's here. Okay, so let's look in here. These are activities. Although here's services. And here's providers. So here's a provider called DB Content Provider. And it is exported. And here's a provider called File Backup Provider, and it is also exported. Yep, that's right. There's two providers, and they're both exported, so they can be accessed from other apps outside the app. Now we can check what permissions are required for these, and this one shows you that this content provider is there. This is DB Content Provider, and here's the permissions. To read keys, you need to have this read keys permission in order to access the path keys. And you need to have read keys and write keys to access keys/star, anything that might be underneath keys. This is going to turn out to be important later, the way that's expressed. All right, these are path permissions. All right, so, so now we can use JADX GUI, which we've used before, a wonderful tool. I'll open another command line and launch it. I say you don't have to use the command line as much as I used to. These GUI tools are quite effective. So the graphical tool, I can now just open that thing in here. I have to go to 128 and then projects. Wait, I'm not in the right place. I need to go, I think web page, yeah. Website, 128, projects, there we go. And now civ.apk, there we are. So it loads it, and there it is. It lets me see all the contents here. And now what I want to do in here is search for content. This is how you find the URLs that go into the content providers. This is not a perfect process, but it's the easiest. So search for references within the source code or the running application for content. So it is navigation search for content : // and it's only looking in the code, and there are 3 examples of URLs that go into that content provider. This is what you need to know, the name of it and how to get there. And see, here's the first 2 are DB, the next one's file backup. And if I can rearrange my screen correctly, we'll see it here. There we are. These are the paths. Content, then the long name of the app, then provider, DB, content provider, passwords, and keys. These are the ones we need. That's how you find these names that lead you in there. And now you can access the content provider with the same command we used before, content query, and that's the URI. So we're going to look at the passwords with content query. So let's go into ADB here. I don't need this open. There. All right, so now I'm going to, right now I'm root. I'm going to exit from root to get back down to, I'm going to make this a little smaller here because I don't want to use the top part of the screen where my face is in the way for the remote people. All right, so there we are. So now, should be able to clear, yeah. All right, so there we are. I can run this thing, and it's going to show me the passwords, and it shows me the username, and it shows me the password. Now, the password is an encrypted blob, and it's not, I don't think we have any way to decrypt it right now, but it shows, anyway, that gives us some access inside the database. We're getting usernames. It's not as bad as getting passwords, but it's pretty unprofessional because I did not have to log in. And then we got SQL injection. Now, SQL injection, we've covered in a lot of the classes, and SQLite is just a SQLite database, and you have to use this projection field to put in data, and you can put in, as you may remember from the other classes, if not maybe the first time you hear it, the way you check SQL injection is first you inject a single punctuation mark like an apostrophe, and that should create a syntax error. And if it does, then you have a SQL injection vulnerability, and you can then put in a carefully crafted request that will work, and you can execute code on the system like, as if you were the developer. So here's the way to inject the single apostrophe. It is pretty messy. So content query, you have to go to the right provider into DB provider passwords, and the projection is quote, apostrophe, quote. That's how you feed a single apostrophe into it. And when you do, you get an error message, which is what you want. SQL exception, unrecognized token from passwords. So that's the point. We broke the syntax with a single apostrophe. That means it's vulnerable. And if you put in a more carefully crafted request, you can now find things. Now, the way databases work is first you have to find the name of the database. In here, we're not going to do that. There's one database, and it's the default database. Then you have to find the name of the tables that you want to query from, and this is the query in this language that will find that. So let me go down here. All right, and so it's going to do a content query of the SIB provider on the passwords, and then what it's going to do, the projection is star from SQLite master, where type equals table. This is the same thing we've done in other languages like MySQL and various other classes. This is going to get the tables that exist in the database provider. And here they are. There are two tables, 1 and 2. First one is named passwords. The next one is called key. Hey there. Anyway, so, all right. And so now we can dump the key table. We can, you just want to see everything from the key table, star from key. So, again, the same kind of query will run, and I do not have to be root to do it. And now I get the password. I get the login password and the PIN. So the fact that I couldn't directly get the stored passwords before is not really a problem, because now I have the login information. I could totally log in and steal them. So this is pretty fatal. All right, and we could also try dumping the passwords table. That was the key table, which is the login password. The passwords table is the table that's protected behind that. And you can dump it, but again, you won't see the password. You'll just get an encrypted blob. But we can log in with this information and get the app to decrypt it. And as I often mention, for example, in the malware analysis class, this is usually the easiest procedure. Rather than figuring out how the encryption works, is to just find their encryption routine and use their encryption routine the way they do. All right, so that's more about internal things. So Samsung had a series of vulnerabilities. I've heard about some new ones. There were some older ones. They had content provider vulnerabilities exposing a lot of confidential data. Because the content providers did not require read permissions. They also had a SQL injection. These things have happened. Content providers may allow other apps to retrieve files by creating a public content provider. If you're going to let other apps use your methods, you have to assume they're malicious. So use a URL, make sure the URL is not malicious. Otherwise, you'll get local file inclusion. And there is local file inclusion in SIB. The file backup providers allow SIB to retrieve a file, but the file name is a parameter you can change. So this will do it. And if you've been taking the web hacking class, there's a whole bunch of projects just like this, where you have a page that's supposed to just show you part of the website, and you trick it into showing you one of the system files. So here, it's going to read, and it's going to go system etc hosts. It's going to read one of the system files instead of reading whatever the developer intended for it to find, and that's the hosts file that gives you IP addresses tied to domain names. We probably could do password too. Let's try that. Nope, okay, that doesn't like that one, but I could get the hosts. Anyway, all right. No, that's how you have to spell it. That's really what it is. I know why. Android doesn't use it. Linux does. Android uses a whole different system for user accounts. That's why I didn't find it. Yeah. Anyway, all right. So anyway, now notice the keys path. We've looked at this before. It is a permission required to read /keys. Okay. The problem is, if you read the Android documentation, which is extensive, you can learn how the path permission works. And the path permission means permission can be granted only to the particular data identified by this path. That means it has to be an exact match. That is going to turn out to be a fatal flaw. So if I try to do content provider /keys and do the query, then I'm going to get, now I'm coming in as just an anonymous user on the system. I don't have any permissions. So it's going to bust me as a permission denial, saying, well, you need to have read keys permission to read those keys. But if I just do it again and I add another / at the end, it still refers to the same object, but it won't match the path permission, so the permission will not apply. So now I'm in. Now I get the password and PIN. That's the problem. What he should have had was a different choice on this menu, like a partial path or something. He should have had path pattern. Then it would be any string that contains keys, or path prefix, any path starting with /keys, but he made it path. That means it has to be exactly this path. And there's a very similar flaw that happens a lot in Apache. Apache has permissions to reach pages, but if you're not careful, they only apply to certain verbs. So it'll block the get, but it won't block the post or the options or the various other verbs. And you can often even just misspell a verb in an Apache server, and it'll bypass the permissions but still be interpreted as a get by the server. So this the kind of thing happens quite a lot. The problem with security measures, they often have little defects. This happened to me in a lab. We were talking about locks recently. I got an electronic lock for a door in the lab, and I installed it, and the students were all there hacking. And I said, well, can anybody hack in here? And they got right in. And I just set the PIN because I didn't read the documentation carefully enough. I had set a passcode, but if you don't take another step, it leaves the default passcode of 0000 there that works too. This happens a lot, that you think you've made it secure, but there's a door still hanging open. Anyway, all right. So then there's insecure services. Services are running in the background, offering some service to applications, and an application can bind to a service, and there are unprotected services that are running. The onStart command receives intents, and there's, for example, clipboard save service was available in Samsung, but the clipboard service could copy files from one location to another, and you could use that by one package with no permissions to install another package. There's been a lot of examples of ways to get past the Android permission structure where you can gain permissions that you were not granted by the user. It's happened quite a few times. Unexported services can, of course, be started and stopped from a privileged account. If you're root, you can bypass all these permissions. And there are bound services, and they work by using something called binder, and these are the remote procedure calls, analogous to remote procedure calls in Windows and Linux, where one app can provide a service to another app. And so you can extend the binder class, or you can use a messenger. These are various ways for one app to request a service from another app. And there's also something called Android Interface Description Language, another form of inter-process communication. And we're not going to analyze these in detail in this class. We're not going that deep in the internals of Android, but it's sort of good to know what's happening behind there. So you can watch the messages that are sent back and forth between apps. Civ has two services. It has an auth service and a crypto service running, and they're both exported. So the auth service, you can examine the source code in JADX GUI. This is the important thing to remember. All Android apps are distributed with the source code. The so-called compiled code is only partially compiled down to bytecode and can be reversed back to Java source code. And that's what JADX does. So you can just read the Java code. So there are some secret codes that have special functions, and they're just hard-coded in the app, which is a very common mistake. So right here you can see one of the codes to check messages is 2354, and to set a message is 6345, and the key code is this, and the PIN code is that. Those are the magic codes that get you in, and you can just see them in the source code of the app, which is distributed with the app. So that means you can request the password from another app. Now, if I had Drozer on here, which I don't have, it's another app that acts like a proxy, so I can make signals from inside the app. I can then, that app can ask for the password and PIN by knowing these secret codes. 2354 and 9234. It'll offer you a service, and if you come in with the authorization key, it provides information to you, and you can put the passwords out of it. This is, of course, a very bad idea. You probably do not want to let any other app gain access to the password by any means whatever, I would think. But they did have somebody get in thinking that these codes made it secure, but they don't make it secure because I can see your source code. Anyway, all right. So then broadcast receivers, these are listening for signals from other apps. They can be unprotected, so an app could take login creds and then verify them with a server on the internet or something, and then send a message saying the app was okay. This is probably a questionable move because I could just send this signal saying, oh, I passed the test. This is what happened to San Francisco parking meters. The hackers at Noisebridge and Joe Grand hacked them a while ago. They found out that San Francisco parking meters would ask your card whether you'd paid. And so you just had to make a card that always said yes, and you're in. They didn't make it. This happens a lot on the web. They ask the browser something important instead of asking the server, and the browser's under your control so you can get your browser to lie and get away with things. Anyway, there's an unprotected broadcast receiver. This has a filter. It'll pick up anything that's correct creds. Any app could send the intent saying, oh, it's the correct credentials, and you're in. This kind of thing happens pretty often too. And the Android codebase back in 2013 would allow any app to initiate and terminate phone calls. So they made malware that would just call a number that costs you money and run up the bill. I was in one of the cases involved. This is a pretty lousy attack because the phone company has a log of it all. So they just refunded all the money. So the crooks didn't get anything. But anyway, it's an attack. And maybe in other countries they actually had to pay. And you can do intent sniffing. You can listen to intents that are intended to go to other apps. You can set up, an app might send an intent with a secret, which is not recommended, like the one we were talking about that passes some secret PIN or something as an authorization key, and all the other apps on the phone could listen to that if they wanted to steal that secret. Any app can sniff it. Drozer can do it. It's an app we may be using in class. We'll see if they've updated that enough. If they have, maybe I'll add the Drozer projects back in. Anyway, you can even sniff without it by just doing, you look in the log for intents, and you'll see the intents in the logs usually. So it's pretty easy to find them. And so, by the way, there are secret codes, and you can find them with Drozer. It can scan for the secret codes, and you'll find them all. Every Android phone does have various secret codes. A lot of them are known, but you can find them with a known API call. And so here's one. This one here will... This is pound star. This one will do something. I've forgotten what, though. Telephony secret code. You might want to not try it on a phone right away. I forget what it's going to do. I'm surprised it's not. There, I test. And this one here, it would open a special page where you could see some phone information and stuff, like your Wi-Fi information and things like that. And there's Galaxy devices had one that would do a factory reset. And you could then invoke it from a web page. You could have a web page that just had an iPhone that executed this, so anybody that visited the page, it would wipe out their phone. That's rude. And I set up a page like that to do a relatively harmless one. Let's see if it works. I just am supposed to do something in an emulator. I don't know if it's going to work in this emulator. I wouldn't put a lot of money on it, but let's give it a try. If I go to a browser, and I go to that page, okay, I don't care who I am. I don't want any stupid sync. How about you stop asking stupid questions and let me use the thing? Is there some way to... This is what I get for using Chrome. Chrome seems to be filled with garbage. Let's see if I have something that's not going to drive me nuts like Firefox. Chrome is too busy trying to sell me junk or something. Let's see what I got. Try Firefox or Opera or something? Looks like I don't. Well, I'll see if I can get Chrome to actually move. Is there somebody... How about no thanks on everything? There we are. Okay, HTTP. Everybody has to bother me with garbage instead of letting me get my work done. info/128/settings. .htm, there we go. And it loaded something in the right page, okay, and here it has, click here, okay. So there's the iframe and it says click there. So when I click there, it sends the magic code, and there it is, sending the code, but it popped up and asked me to call. That's a modern feature. After people did this all the time, they said, well, you have to verify it. So if I do the call, okay, then it looks like No, it looked like it didn't really do anything. All right. Anyway, on some emulators, it will do something like pop up a configuration page or information about the Wi-Fi or something. Anyway, let's try a Kahoot. And then we'll do some demos, which are going to be more exciting than usual. So now here's the Kahoots. Let's see, I got to go somehow to here, 7B, there we are. All right. There we go. Good. Oh, good. I know you go up and down with them. Most students like it. It wakes them up. What's that? Wish your score was enormous? Anonymous. Oh, well. Well, you can use a fake name. Oh, I know. But you could use a fake name. That's how you make it anonymous. Yeah. There's a competitive nature. That's how CTFs work. There's people have this competitive nature. They want to win, even when there's like no prize or anything. What's that? That's why I stopped. Yeah. Oh yeah. I remember when I was married, my wife said she'd never play with Monopoly with me again because I was so ruthless. I could talk them into doing stupid things. All right. Well, anyway, all right, here we go. All right. So which item makes a screen pop up and can be launched from Droser? Right. An activity is what makes a screen appear, and it has to be exported if it's going to be launched from a different app. All right. All right, which one may be vulnerable to SQL injection from a different app, like Droser? Yeah, it's got to be exported, and the content providers are the databases that can be SQL injected, if they're vulnerable. All right, which one allowed privilege escalation on Samsung devices via the clipboard? It was a service. It was an exported service. All right. And which component can be used for intent sniffing? The receivers are listening. Normally they filter and only listen for certain things, but you can listen for everything. All right. All right, I'll bring it now. It's going to be. This is CNIT 8. So, I got 3 parent, B, and 3 bone, SF, and, come on, sheep. Okay, good. All right, good. Stop this. All right, now I'm going to stop this recording, if I can find the right place to go.